Okay, so the next talk is by Burak Yelmen, who will tell us about convolutional and conditional neural networks for genetic data generation.
Thank you all for this nice opportunity. So today I'll briefly pitch you our project and well, how do we it's a bit tricky. Do you have any idea how to do this full screen? Okay, so I'll briefly pitch you our project, and later on, hopefully in the next section, you will hear more about these from Flora also. So maybe the first notion is why do we want to create artificial genomes? Why do we want to do generative modeling for genomic data? I mean, of course, it's first of all very cool and very interesting to see if we can capture this complex distribution by generative modeling, but also our main goal was the accessibility, increase the accessibility of genomic data. Although there's now the amount of genomic data is increasing immensely every year, but there's a bit of an accessibility issue. Like many of this data is both for private institutions and public institutions. You need to either go through some application procedures, ethical clearances, maybe you need to commit to even collaborations just to test ideas. So our idea was that if we can maybe create really good surrogates for real genomes and which have most of the good characteristics but cannot be traced back to the original data, maybe people can do analysis on this. And later on, maybe these can be used as to create surrogate databases, surrogate biobanks, so that people can use them, access them publicly, just like maybe you access 1,000 genomes database. And for this, we would like to test generative modeling, generative neural networks. Okay, so in 2021, we published our initial research, and there we used generative adversarial networks and restricted Boltzmann machines to create artificial genomes. I won't go into details here how these work, but what we did was we generated artificial genomes and we tested them in terms of many quality metrics. Here you see like whether they can capture, it's a PC analysis, you see like if they can capture the population structure present in the original data. And we checked haplotypic integrity and privacy measures and many other things. And we also showed that these can actually be used in real applications. We showed that if you use a reference panel, additional reference panel, you can actually improve the mutation scores using artificial genomes. But there was a main huge issue because these were all very small segments. Main reason behind this is because these were fully connected architectures. And as you can see, even for small segment which only has 10,000 SNPs, the computational complexities, you need to train millions of parameters. And also for GANs especially, they are very difficult to train. And to overcome these, to address these issues, this is our new preprint, you can check it out for details. And we proposed two new models. One is a Wasserstein GAN with multiple additional modifications, which I think maybe I don't have time to go into, but it's a very deep architecture using the convolutional and deconvolution layers mainly. And the other one is a conditional RBM, which is the main idea is that training multiple RBMs or multiple genomic regions which has shared sequences, shared regions. And again, we use these models to train and generate artificial genomes. And again, we tested them with various metrics. Here you see again if they can capture the population structure. Here you see the LD blocks, the LD decay, and allele frequencies, and many other. And also we checked them in terms of course, that's a major goal, in terms of privacy leakage, whether they can be traced back to the original training data. This is of course developing ongoing research, but there are some interesting findings here. And with that, I think if you have further questions, if you're interested in, I think we have also a poster today. And I would like to thank everyone involved, especially Flora, who's been the main guiding voice in all these projects, Aurélien, who's been developing the RBMs, and Guillaume and Cyril for their valuable insights. Thank you.
Yeah, if you have further questions, follow up with
yes.
post session.